Imagine floating in the vastness of space. No sound, just silence and cold. Bone-chilling, unimaginable cold. But here's the mind-bending part. The sun is right there, blasting 27 million degrees Fahrenheit from its core. So why would you freeze to death in minutes? And why can't you hear the explosions of distant supernovas? Today, we're unraveling one of space's most fascinating paradoxes: why the universe is simultaneously the coldest and quietest place imaginable. And trust me, the answer is going to completely change how you think about empty space. Let's dive in. First, let's tackle the cold. Here on Earth, we think -40 degrees is brutal. Antarctica can hit -128 degrees Fahrenheit. But space? We're talking about -455 degrees Fahrenheit. That's just 5 degrees above absolute zero, the coldest temperature physically possible in our universe. But wait, how is this possible when the sun is constantly pumping out massive amounts of energy? Here's where things get interesting. The answer lies in understanding what temperature actually is. Temperature isn't some abstract concept. It's literally the measurement of how fast molecules are moving and vibrating. When you touch something hot, those rapidly vibrating molecules transfer their kinetic energy to your skin. When something is cold, those molecules are moving slowly, transferring less energy. Here's the key: you need molecules in the first place. On Earth, we're swimming in an ocean of air. Trillions upon trillions of nitrogen, oxygen, and other gas molecules surround us at every moment. These molecules can absorb heat, hold heat, and transfer heat. When you step outside on a cold day, cold air molecules crash into your skin, stealing your body heat. But space? Space is the most perfect vacuum in existence. In the interstellar medium between stars, there might be only 1 atom per cubic centimeter. That's essentially nothing. No molecules means no conventional temperature, the way we experience it. To understand why space is cold, we need to understand the 3 ways heat can travel: conduction, convection, and radiation. Conduction is heat transfer through direct contact. Touch a hot stove, and heat conducts from the metal into your hand. Through molecular collision, convection is heat transfer through the movement of fluids or gases. Hot air rises, cold air sinks, creating those convection currents that heat your home. Both of these require matter. Molecules bumping into each other, transferring energy. But in space, there's no matter to conduct or convect heat. That leaves only radiation. Heat can radiate as electromagnetic waves, infrared radiation, which doesn't need any medium to travel through. And here's the brutal reality for an unprotected astronaut. Your body constantly radiates heat into space through infrared radiation, but there's almost nothing there to radiate heat back to you. You're losing heat, but not gaining any. It's a one-way street. The sun does radiate enormous energy, yes, but space is so vast, so empty, that this energy is spread incredibly thin. There simply aren't enough molecules present to absorb that energy and create what we'd call warmth. If you were suddenly exposed to space without a suit, you wouldn't instantly freeze solid like in the movies. Because there's no air to quickly steal your heat through conduction, you'd actually radiate heat slowly. But make no mistake, within seconds, the fluids on your tongue and eyes would start to boil from the lack of pressure. Within 15 seconds, you'd lose consciousness from oxygen deprivation. The cold would be the least of your problems. Now, let's talk about the silence. And this might be even more unsettling than the cold. Think about the most violent events in the universe. Stars exploding in supernovas, releasing more energy in seconds than our sun will in its entire lifetime. Black holes colliding, rippling the very fabric of space-time. Massive solar flares erupting from the sun's surface. All of this unfolds in perfect, absolute silence. Why? The answer comes down to what sound actually is. Sound is a mechanical wave. It requires a physical medium to travel through. When you speak, your vocal cords vibrate, creating pressure waves in the air. These waves of compressed and decompressed air molecules travel outward, eventually hitting someone's eardrum, which vibrates. Their brain interprets those vibrations as sound. No air, no vibration, no sound. Space is the ultimate anechoic chamber. With essentially no molecules to vibrate and carry sound waves, there's nothing to transmit sound. You could detonate a nuclear bomb in space, and a person a mile away wouldn't hear a thing. They'd see the flash of light, they might feel radiation, but no sound wave could reach them. But here's where it gets really interesting. There's an exception to space's silence, and it happens inside spacecraft. Astronauts aboard the International Space Station can talk to each other normally. Why? Because inside the station, there's air. The spacecraft is pressurized with a breathable atmosphere, so sound waves can travel just like on Earth. If you were inside a spacecraft and knocked on the hull, you'd hear it clearly. The sound waves travel through the metal, through the air inside. But if your fellow astronaut was outside on a spacewalk and knocked on the same spot, they'd see their hand hitting the metal, but hear nothing. And you inside might hear a faint vibration conducted through the hull itself, but nothing like a normal knock. This creates surreal situations during spacewalks. Astronauts communicate entirely through radio. Their voices aren't traveling through space as sound. They're being converted to electromagnetic waves, transmitted through the vacuum, and converted back to sound inside each other's helmets. Even more fascinating. Earth's atmosphere extends farther than you might think. At the very edge of the thermosphere, about 600 miles up, there's still an incredibly thin atmosphere. It's far too thin to breathe or carry audible sound, but technically, sound waves could travel there. It's just incredibly slowly and weakly. So what does all this tell us about space? It reveals something profound about the nature of our universe. Space isn't just empty. It's a fundamentally different environment than anywhere on Earth. It's a place where our everyday intuitions about hot and cold, sound and silence simply don't apply. The cold of space isn't like the cold of a winter day. It's the absence of heat transfer mechanisms. The silence of space isn't like the quiet of a soundproof room. It's the absence of the medium that makes sound possible. This is why space exploration is so challenging. We evolved in an environment rich with air, where heat transfers efficiently, where sound warns us of danger. We're adapted to a world that's the complete opposite of the space environment. Every spacesuit and spacecraft has to artificially recreate Earth-like conditions, maintaining pressure, managing heat through careful insulation and active cooling systems, providing air for both breathing and sound transmission. The next time you look up at the night sky, remember this: you're looking at a realm of extremes, a place where the absence of something as simple as air creates conditions. It's almost incomprehensible to our Earth-based experience. Space is cold, not because cold exists there, but because heat has nowhere to go and nothing too warm. Space is silent, not because sounds are muffled, but because sound itself cannot exist without molecules to carry it. It's a reminder that the universe doesn't care about our comfort or our expectations. It simply is operating according to physical laws that create environments ranging from the familiar to the utterly alien. And yet, figured it out. We've understood the physics, engineered solutions, and sent humans into this hostile void. That's the real story here. Not just that space is cold and silent, but that we understood why, and we went there anyway. If you found this fascinating, hit that like button and subscribe for more deep dives into the physics of our universe. Drop a comment below. What aspect of space exploration amazes you most? Until next time, keep looking up and keep questioning everything.